Hi, welcome to 3D Printing Essentials. I'm Emmett Lalish, this is Chris Iverson, and we're here to talk about 3D printing and what Microsoft is doing in this space. My background here is I'm actually an aerospace engineer. They don't have that title here at Microsoft, so I go by mechanical engineer. And I was, up until last year, designing unmanned vehicles and such for DARPA, flying, underwater, etc. But as a hobby, for the last few years, I've been designing 3D printed things and 3D printing in my home, just as a consumer. And that has been really fun, and it led me eventually to meet Chris Iverson and the team here at Microsoft, who hired me, and I've actually joined in the team. So now I'm actually helping to guide that process and figure out exactly how we're going to make 3D printing easier for everyone.
Great, yeah. I love working with Emmett. So I'm Chris Iverson. I'm a software design engineer at Microsoft, and I lead the development team responsible for 3D printing and the innovation that we're sticking in Windows. Emmett and I both work in a group called the Operating Systems Group, and we're really looking at how 3D printing is done at Microsoft and adding innovation into all our products across the company. So today we have broken out for you a bunch of course topics. We're going to do an overview of 3D printing. We'll talk in depth about the hardware that we support and exactly how it works and show you how to set up a printer and calibrate it and all the kind of messy stuff that goes with 3D printing. We'll talk about 3D printing software that you can use and also our model repair service, which is a very important feature that we recently added into our portfolio to make it possible to print any kind of 3D model. Well, I shouldn't say any kind, but 3D models that you would find on the internet. It makes them ready for 3D printing and successful. We'll do an end-to-end 3D print for you and show the full printing process, and we'll put that on camera. And you can maybe we'll make a mistake or two, and you can kind of see what the real consumer experience looks like today. And I also brought a Kinect camera here, a Kinect sensor, and we'll try to show you Kinect Fusion and how you can create a scan and import that thing into our 3D Builder application and do some really fun stuff with it. And then, of course, Emmett is a preeminent designer of 3D models on the internet, and we're going to go through a bunch of his designs and let him talk about how you need, what things you need to think about when you design a model to be 3D printed. And we'll show a bunch of these examples that he's got, these really cool ideas he's got here on the table. And then we also want to share with you some opportunities that we see at Microsoft that you can take advantage of in this 3D printing space around Windows apps and any other opportunities that we think we're uncovering with our work.
So now we're going to talk about, basically, we're looking for, talking to everyone here. I mean, a lot of you are engineers, some of you are designers, programmers, hobbyists like I was and am. Kids, of course. All of you have some interest, hopefully, in 3D printing, and certainly 3D printing has opportunities for everyone in these categories and such. So
I think 3D printing is one area that really crosses all different kinds of job titles and trades, and whether you're a designer or an engineer, somebody that works with 3D models on a daily basis, you'll find this to be a new and interesting tool to get work done. So we want to show you today a bunch of the things that you can do with 3D printing, and I hope that no matter what you do, you find this to be an interesting talk, and you can find a use for this in your workshop. So let's just start out with a quick overview of 3D printing.
Yeah, so we have this ability to create things, which is pretty amazing. So this is actually a coworker of ours who was scanned with a high-end laser scanner, and we've got a very highly accurate mesh 3D model of his bust. And then basically you can just take this and print it and make a likeness in really with very little difficulty. And we're going to talk about basically the process behind all of this and what makes this possible.
So what is that thing on the right there? What is that material that's sort of materialized into?
So this, I believe, is a print in ABS, which is the same kind of plastic as like Legos and drain pipes and such are made of. It's a nice, strong plastic. There's a number of others that we use as well, like PLA is a biodegradable polylactic acid plastic. There's many other things you can potentially print in. These are sort of the most common ones at home for these sort of consumer-level 3D printers.
So how big is that actual object on the right?
I recall it being about 2 inches tall.
Okay. So that's pretty. I mean, that's pretty amazing detail you can see on the face and in the hair and stuff. So, like, what kind of like resolution what does a typical 3D printer in the consumer space? What is it capable of?
I mean, it all depends on how you think of resolution. A lot of the easiest way is the layer thickness, because everything is printed in layers, and these are about 200 microns thick. But realistically, the positioning accuracy of the printer is actually quite a bit finer than that. So the level of detail and sort of the curvature of his face can be down even as low as like 5 microns.
Oh, that's amazing. So at the very bottom of that picture, I can see like there's some strands or some stringiness. Why does that happen, and why is that in that model?
Right. So this particular model was built in such a way that sort of it's a floating bust, if you will, sort of like maybe one of those statues you've seen at a museum where the bust is sort of carved and then it's sitting on top of a little pedestal. And the trick is that that pedestal is smaller than the bust, and so there's what we call an overhang underneath it. So basically it's very steep, and these printers have to print on top of something. They're physically squishing the plastic down, and if there's no plastic underneath them, it'll just sort of fall. And that's the little stringiness that you see at the bottom there. So when we look at this kind of design, you have to think always in terms of what is the manufacturing method you're planning to use. Every manufacturing method has its details of basically what you need to think about. You know, if you're going to mold something, you have to be able to release the mold. Well, if you're going to 3D print something, you need to make sure that your overhangs are not so steep that everything will fall down. There are some ways around this. There's automatic support generation. There are other types of 3D printing that handle these overhangs better. So there's a lot of options.
So that's really cool. Okay, so we're going to get into a lot more detail about support material and designs and all that later, but let's just kind of go through and talk a little bit more generally about 3D printing and where we see opportunities and what's different about it.
Yeah, so I mean, here's the additive manufacturing process, and it's really different. What we're showing on the left is basically this is how manufacturing was, how it's traditionally been. When you think of injection molding, when you think of maybe machining parts and that kind of thing, the basic idea is in order to make it cost effective, you have to make a lot of something. You have to turn it into an assembly line and be able to create thousands or hundreds of thousands to make it feasible. So that standardization is really important, whereas in 3D printing, with additive manufacturing, you can just basically making one of something is the same price as making 10,000 per object. So it suddenly means it's feasible to actually make single things, exactly what you need at a time. It's not going to compete for making 100,000 identical objects. For that, traditional manufacturing is still better. But it's pretty incredible, basically opening up this possibility that you can just have exactly what you need, something specific. It can be highly complex. There's no longer really any cost associated with the complexity of the model. It's really just a size thing. You can look at basically the idea that you can make something all at once. You don't necessarily have to have a line where you're building a bunch of parts and assembling them. A lot of times the reason you do that is because the manufacturing process in the first place couldn't build the part the way you wanted all at once, so you had to break it into pieces. A lot of times, because of the flexibility you have in 3D printing, you can actually make it all at once the way you want to begin with and simplify the process. And this is potentially even true of assemblies. I mean, we can actually make things that move and we're all printed at once and can't be disassembled. And this is something that's just not possible with traditional manufacturing.
So when you think about traditional manufacturing, you talked about injection molding, and also a lot of people are probably very familiar with CNC machines and how they work. Like, can you just briefly describe the difference between additive manufacturing and CNC and how that sort of applies to that model there? Like, why couldn't I build that same model with a CNC machine?
Sure. So, I mean, In a lot of ways, especially when it comes to the mechanics of the printers, a CNC machine and a 3D printer actually have a lot in common. They have these sort of computer numerically controlled axes that move around in 3 dimensions. But the big difference is the idea of additive versus subtractive manufacturing. The traditional CNC approach was you take a solid block of metal or whatever your material is, and you cut away everything that's not the part you want, right? It's just like sculpting, right? You know, if you want to make a David, you take a giant block of marble and you cut away everything that's not a masterpiece. And that's great, but it wastes a lot of material in the process, and it can be very difficult to actually cut away those narrow nooks and crannies of a complex part. Whereas with 3D printing, you actually start with the raw material and you build it up a layer at a time. And because you're building a layer at a time, you're actually able to access the whole geometry of the part, the whole internal structure, sort of before it's internal. And you can therefore create these very complex shapes. They can have hollow spaces inside, voids. Things would be totally impossible with a traditional machine, and it'll work just fine. It's really just a matter of how long it takes to put out the material that will create the part.
That's so cool. So, I mean, I'm always really interested in seeing what additive manufacturing can do you can't do with other types of manufacturing processes. So we've talked about the ability to customize a part and personalize it to make one-off instances. You can represent these things as assemblies, like actually assembled products that you can pull right off the print bed. And Emmett demonstrated that with his gear bearing. And this is also excellent for small run production. But you mentioned that you couldn't do large scale manufacturing with 3D printing. Is that true? I mean, is there no place right now? Do you think for doing an actual final product at scale using a 3D printer?
There are absolutely places. They are somewhat unique places. Again, it's generally not going to be the case where you're going to want to make 100,000 of something with 3D printing. But there are a lot of cases where things are, for instance, not quite so huge of production runs. I mean, I'm from the aerospace industry, right? We build aircraft. Sure, we have assembly lines, but we're not building hundreds of thousands of them usually. We'd love to, but it's just there's not that many. And so sometimes you can look at basically doing parts of actual jet engines, and you can build them directly out of the proper kind of metal that you need for a really complex, difficult geometry. And simply because you can create a part that's more complex than you could machine any other way, it's worth it to be able to actually, even though it takes quite a while to create this part, it's still, you can do a better job, it can be more accurate, it can be more optimized, and that's a really powerful thing for manufacturing.
So I love this concept. You're sitting at your desk and you're iterating on a design. Maybe you work for a big manufacturing company on an airline or a car or automobile or something. So you're actually using an inexpensive 3D printer to get your job done and try the part out right there on your workstation. And then when you're ready, sort of Microsoft's vision here is that you can take that part and you can send it to a commercial fabrication process. That may be a 3D printer, or it might be some other traditional fabrication process. And Emmett actually is holding a really cool print. This is probably my favorite print that I've seen this year. You can see we started with a 3D model. We then printed it in plastic, with just using an inexpensive desktop printer. And then Emmett has great connections in the industry and was able to get this part printed on a very high-end metal printer. So
that's right. So this was using a metal sintering machine. So we start with plastic. This is the kind of thing I'm making on my desktop for a machine that costs next to nothing compared to this. I mean, this is orders of magnitude more cost for the machine, but it also allows us to make this same part out of a cobalt chromium superalloy. One of the most heat resistant, wear resistant kinds of material that we've ever created. This is the kind of stuff that you can put into a jet engine and expect it to survive in those kinds of conditions. So the idea of rapid prototyping is a huge part of 3D printing, because prototypes are sort of by definition short run. You just want to try one and see if it's what you want.
I mean, you're not actually talking about rapid prototyping. In this case, you actually printed a part that we think could be put in a final assembly. So
that's exactly right, but I prototyped it first.
Yeah, right.
And so that's the real beauty.
So that's really cool. I know I talked to partners of Microsoft, and I know there's a lot of excitement in the manufacturing industry for this idea of the iteration at your desk, the ability for an engineer to have one of these inexpensive printers, so they can unlock their design process and their creativity to get their job done. And they guarantee, well, they more or less guarantee that part that they're working on is very precise, is exactly the part they need, and then they can send it off to a production run, whether it's through a 3D printer or to some other fabrication process. They can get that exact part that they were looking for. They know that it's going to meet their specifications. So that's a really important piece of what Microsoft is interested in here, is really connecting that inexpensive printer to the corporate or commercial printers, which probably most consumers and even most employers will not be able to afford those high-end devices to get like the metal that Emmett showed. But we're going to try to make it possible for you to send that model out to a place where you can get that done. So just to summarize, we just gave you a quick overview of some of our thoughts in 3D printing, and gave a little taste of some of the important areas that we're focused on and some of the problems in this space. And next, we're going to really just take a look at the hardware. And again, we're mostly focused here on the consumer hardware devices, the kinds of things that you would access, that you would have available in your home. And we're going to go through and show you kind of the anatomy of the hardware and help you familiarize yourself with how to set one of these things up so that you can print to it.